Welcome to Escalation. As an introduction to Python for beginners, we were discussing about the data types in our previous video with some very simple syntaxes for each of them. In this video, let's discuss numbers alone in detail. Coding in Python is for everybody as it is known as a very simple language and is called as dynamically typed, which just means we don't need to define the type of a variable. Instead, it's determined based on the value assigned or the syntax itself. For example, I will initiate a variable x and assign a value 10 to it. Now, if I check the data type of x, it will be considered as an integer automatically. Numbers in Python can be integers, floating point, complex, Boolean, hexadecimal, octal, and binary too. We will look at each of these types in detail. Starting with integers, clearly it can be either 0 or a positive and a negative numbers. Let us look at some simple operations like addition. As we are using Jupyter Notebook, we can perform mathematics directly without a variable by just typing numbers along with operators. Now we will try the same with variables. We already have a variable x created above with a value of 10. Let me initiate another variable y with a value of 15. Now we can use these variables with operators like minus to perform subtraction, asterisk to perform multiplication, and a forward slash for division. When it comes to floating point, it's just by adding a decimal to an integer converts the variable type to decimal automatically. Interestingly, by just adding a point converts the type to float. Let's try similar operations by creating two variables x and y. It works the same way with addition, multiplication, etc. If you notice here, we are creating a same variable x and assigning a value of 15. Is it overwriting previous variable? No. And we can confirm by looking at the memory location of a variable. In my previous video, I had spoken about an object having type, value, and an ID. Let us look at the memory location of this variable where we are assigning the value 10. Now, we will look at the location where the value of x is 5. The locations are different. That gives us the explanation of immutability of the data type integers. Integers are immutable, which means whenever a value is changing from the same variable, it will create a new object instead of overwriting the existing. Hope you understood what are mutable and immutable objects. We will understand it much better when we talk about lists in our upcoming videos. Floating point values can also be exponential by adding a letter e at the decimal. Here, e is not case sensitive. The exponents can be positive or negative. When we are doing calculations, any one object being a floating point is enough to convert the result type to a float. Let us just add number 15 to 0.2 or even 15.0 to 2, it returns a floating point automatically. Another good thing to notice is, be it any fraction between a whole number or a normal, a decimal or a floating, fractions always return a floating point object. Python also supports a normal notation for complex numbers. The real and imaginary parts are separated by a plus or a minus sign, where imaginary numbers are used with a single suffix of letter j. Here, the letter j is also not case sensitive. We can also try performing some operations like adding two complex numbers. Adding a complex number and an integer also returns a complex numbers. Python also lets us fetch real and imaginary parts of a complex number by using attributes of the variable where imag will return the imaginary part and real will return the real part of the complex number. Boolean is nothing but true or false values. Note, the values must be in proper case or you would be seeing a name error. Operations that can be performed are logical bitwise operators, which we will discuss in detail later. But for now, let's just see some examples to check if two variables are same. If I check the result of this variable, it will be a Boolean. Apart from these, If you know what are hexadecimal, octal or binary numbers, you could relate to these types. These are some of the type which you would not be using at least while learning Python in the initial days. However, to complete the integers data type, these are necessary. These are base numbers in mathematics where the bases are 16, 8 and 2 respectively. Just keep in mind that these are simply an alternative syntax for specifying the value of an integer. To create a hexadecimal number, we should be using the syntax 0 followed by letter X and then continuing with digits and letters, where every digit must be between 0 and 9 and letters can be either A, B, C, D, E or F. Similarly, an octal can be created with the syntax 0 followed by letter O and then continuing with digits where digit must be between 0 and 7 and no alphabets. And binary can be with letter B and digits being 0 or 1. Note the syntax with alphabets here are also not case sensitive. This completes the necessary part of integers to start. We will discover a lot more while we work on some of the examples. For the next video, we will discuss more on strings in detail.